All right. So, guess what? I deleted my temp directory. So, don't be me. I do stuff in temp all the time because I don't have to clean it up when I reboot my computer, but I had to reboot my computer because I wanted to be really fast and have no packet loss, even though I've already had a few drop frames. I can't explain it anyway. So, what do? We avoid that. Now, it was a stupid little script, so I don't mind losing it, but you probably do. So let's do this. I haven't covered this yet in the beginner boost, but we're going to cover it in at least this time. But we're going to go ahead and cover it. So if you do not have a GitHub account, pause the video right now and go add a GitHub account unless you're under 13, in which case go talk to your parents about what to do. If you add an account and use GitHub and you're under 13, it's not my fault. Right? It's against the Child Online Protection Act and it's illegal. Big time. In fact, every violation of that, every single time you use the service and you're under 13, you can be fined $16,000 for each time you access the service. So, I'm not telling you to do that. If you do that, it's on you. But, that being said, if you're 13 or older or you want to live dangerously or whatever, then we're going to use GitHub. Why? Because we're going to save our code. We're going to figure out a place to save our code so that we can put it up there and it's up there for us to go get anytime. Okay. I will make a separate video about how to use a bare Git repository as your backup instead of GitHub. But let's be real. GitHub is the place for you to do it if you have access to it. Okay. So the first step one is to go create your account on GitHub. Don't do anything else until you've done that. Once you have the account on GitHub, make it lowercase, by the way. It's something you're going to remember, preferably the same name as what you have on your computer. And then once you have that done, let's go ahead and look at what comes next. So this comes down to organizing your repository into a way that you can get to everything. You can see a bunch of stuff. This is a Mac. It's a Unix machine that's got all these things. If you're on a Linux machine, a lot of times you have these same initial uppercase letters. I don't mind that. It does bother me a little bit because it's not Unixy, but it doesn't matter. That's the way everybody's decided to do it, whether it be Mac, Windows, or Linux. WSL2 doesn't have anything in there. But if you're in your Windows home directory, you have the same thing. So they're not standardized, but they're the same. But the thing that's nice about that is then your scripts can do the same thing. So I have a script like, for example, move last. It automatically looks into the downloads directory on any of these systems, assuming the downloads directory has a capital D. And based on that preference, I went ahead and made something called a repos directory. So inside of the repos directory, let's just look. Inside of the repos directory, oh my gosh, there's a lot of stuff there. Yeah, well, that's probably not the thing to do because repos does have all the Git repos and tree does not eliminate those. So whatever. Anyway, so there's a bunch of stuff there. So let's cd into repos and you can see github.com. And then inside of github.com, you see a number of other places. Like these are all the people that I've cloned from in the past. And I have an automatic script for that I'll show you about later. And then, so we go into GitHub and then you'll see mine in here as well. RDX Rob, and you'll see that there. Okay, so let's make that. Here's how you do that. Make dir -p. Oops. Make sure you use your exact name of your GitHub repo. Repos / github.com / RWX Rob in my case, whatever yours is. And then that'll make it for you, okay? Now we're going to go back into it. So we're going to use the history. So if you're not using VI mode for history, which you should be, then set -vi. And then we're going to push up, go up in the history. We'll go back up again. And now we have make dir. I'm going to change these things. I'm going to change those two words, C to W. And now, oops, it didn't change them all. It almost changed them all. So let's go ahead and use it. Let's say now we're going to CD space. And then we're going to X that out. And then we're going to hit enter. And that's going to take us all the way down into there. So that trick about editing your history using VI mode is really powerful. It's by far the fastest way. It's way faster than Z Shell, and it's universal. It works in any Unix system ever made. So you don't ever have to worry about Z Shell not being on the box and having stupid things in your muscle memory because it'll just work. So using set-ovi is very powerful, and that's all I'm going to say about that. So now I'm in the right place, and I'm PWDing to see where I am. And there's nothing in here in your case. So the next thing too, we need to install Git and GitHub in order for this to work. So I'm on a Mac. So if you're on a Mac, it's brew, install Git and GitHub, and that will go grab the latest of Git and the GH command line tool. So that'll get it for you. If you're on a Unix machine, apt, you do sudo apt install git GitHub. Oops, Git and GH. I am not on a Linux or WSL machine, so I'm not going to do that. Okay, but that's what you would do. That's the command. They're both included. You don't have to do a custom PPA. If you see my dot files, that's no longer needed. I spent a lot of time figuring that out just now. So, okay, so that's all you need for that. Now, once you have that, you can GH auth login and you hit enter, and you can go ahead and follow the steps to authenticate. When you get to GitHub, you hit GitHub, HTTPS, authenticate using HTTP, yes. Log into the web browser, you hit yes. And that's going to give you a code, and then it's going to say, do you want to open your web browser? And you say yes, and it'll pop open your web browser. You authenticate, you type in all the things, and then you hit enter on that or whatever. You click on enter on the website, and it will come back and it'll say, huzzah, you're authenticated. Okay, that's pretty basic stuff. It's really fast and easy. Once you have that, you can do GH status, and that will tell you the status of, well, wrong thing. That's cool though. That's like a summary of all of my statuses. I got to start using that more. What I meant to do is this, the auth status. So this tells you all the things that don't, there's a token. It says, hey, I'm logged in. In the old days, another way to do this, if you just want to use Git, is you can do SSH. We've been doing this for years, Git at github.com. And that will tell you that you've been authenticated and that you're ready to go. And it just, blocks you out. That's the old way of doing it. Trying to dox real hard. No, I'm not. I knew that wouldn't dox. So anyway, so now we're all ready to go. What comes next? All right. So now we're going to make a repo. We're going to make your .files repo. I'm not going to get into why you have a .files repo. You can go do a search on there for .files on GitHub, and you'll see there's tens of millions of .files. It's like a rite of passage to create your own .files directory. That is normally the first repo you're going to create. If you don't have one of those yet, go ahead and make it and start using that to put in, your configurations and stuff like that. But now I'm assuming you've already done that and you've got your configurations kind of set up the way you want. You can kind of move them in there and thing. I will be covering that in the book quite a bit, but for right now, that's just, I'm skipping that because we're working on Bash. So the next thing we're going to do is we're going to make another repo, and it's probably that you can be the same one if you want, but I call this repo lab. And the reason I call it lab is because it's where I put all my notes in. Some people call it notes. Some people call it a code book. Some people call it, there's a million things you can call it. What it is it's a combination of code, and it's basically your own textbook, right? It's all your notes plus all your code snippets and everything. It's all in there, and it's there for you to go in and peruse and look at and try around. And so you have to decide if you want to make it private or public, if you want to share it or not, if it's going to represent your best code for other people to see, or if it's just something you want to just be able to dump random stuff in there and not really give up where you want to do there. Once you have decided all of those things, then you can go ahead and make one. Now, I've already got one, so I'm going to show you the command for this. So gh repo create -- private -- clone, and I'm going to create, and we're going to call it lab sample. Okay, so mine is called, you can call it a spell book if you want. Yeah. So we're going to call it lab sample. Okay, so this did a lot of things all at once, and I just want to tell you, people say, why are you using GH for all that? You have to teach them Git and everything. I'm like, no, I don't. You know how many people don't know about this? My entire team at work has no idea. Every time I show them this is the comment they say, I need to learn that GitHub command. I need to spend some time to learn that. Yeah, you really do. Okay, this is one of those things where people are like, why aren't you learning the V language? And I'm like, because I need to help people learn about the GitHub command line tool, which has relevance. There's people who are learning V and Nix who don't know how to use the command line tool, but yet they could be using it every day at work. I rest my case. All right, so anyway, that did all the things necessary to get that thing here. So now all I have to do is CD into it. Pretty cool, huh? That's why GitLab has stolen it straight up and not even changed references to it in order to do it, because it's so freaking powerful. Now, it did a few things wrong. For example, it actually named this master instead of main. And so we're going to fix that right away. This is a Git thing. Is it Git branch? I think is it Git branch dash M main? I think that's it. Yeah. Git branch dash M main, that changes it. And then we haven't saved anything here yet, so that's okay. And then what? So we don't have a README or anything in here. So let's actually go ahead and make a README really quick. I promise we're getting back to the bash. I just wanted to take a note to do this. So we're gonna do the README. Let's say my personal lab stuff. Mostly messy or whatever, right? Save it. And then what? Now we're going to save it. So git status. These are commands that are all going to go in your notebook, right? So let's do git add dot. If you don't want to add an individual file, just add in git add dot. Just remember that command. It's a nice, good one. And then git status will show you that it's ready for committing. And then you can go, both main and master are misleading. All branches are co-equal. Yeah, I don't want to get into that. Git commit dash M. If you don't do the dash M, it'll dump you into this, which is fine. But, just do git commit dash M. You can make that into an alias if you want later. And this is just like one command. Or you can make all of this into a single alias command called save, which I'll show you about in a second. So you can do git commit, and you can say, because we're just saving stuff eventually. We're not using git for PRs and all this stuff that you'll eventually learn, but now it's just a backup method. So git commit dash M, it could say update readme. I do think you should have something relevantly, relative here. So git status. All right, what's going on? Why is it taking so long? Am I dropping frames? This should never take that long. Oh, I don't know what happened there. Okay, so seems to be git status. Nothing to commit. What just happened? Ad break. The ad break is loud. I'm sorry, the ad break is loud. I don't know what's going on here. I did not push it. I just changed it. Did it automatically push? What is going on? What just happened, people? It seems like it pushed automatically. I know it didn't show in the git status. That's what I'm serious. Something's weird. Something's not right. Oh, you know what? It didn't show us because it's never been pushed. And it's on main. That's why. Okay. All right. Because we changed the branch name. Yeah, no, it's because we changed the branch name. That's what's going on. Okay. I'm glad that happened live. Because I changed it to main, and main it hasn't been pushed to GitHub yet. So GitHub doesn't know about it. So let's do this. Let's do git. Yeah, I can do the git restore. That threw me. That threw me. So maybe that'll help somebody else. Because it's like, you don't have anything to push. It's like, no, this is totally fine. And that's because nothing to commit. You're working on tree clean because it doesn't know about it up on GitHub yet. What? I did not know that. All right, so here we go. Git push. And we're going to do git push. It's like, nope, can't push because remember we did the renaming thing? So we need to do that. So we go to git push -u instead of that. If you want to type that, you can. I don't. Origin main. And that'll push it up. Okay, here we go. Git status. Now, if we make a change now, mostly messy stuff. Let's do the same thing again. Git add dot, git commit, stuff, git status. There it says you're one head of main because it knows now. It's like synchronized. It wasn't doing that before, and that threw me because I hadn't pushed the branch yet. So, so here we go. That we can do this. We can say git push, and that will actually push it all up. Okay. One last thing to show you is about what you can eventually do. Mostly messy stuff here is you can eventually write a program like this. VIC save. We're going to get there. It's one of our projects one of the projects that we're going to do is we're going to write a bash program called save that does a git save for you. And that is one of our projects. But right now you can just type save, add more stuff to README with no quotes or anything. And it'll actually do the commit, the pay, and it also pulls down the latest. So that way you get, a nice happy log of all the commits to everything you did. So, I don't recommend it. My save is actually so generic that if I don't give it a title, it just saves it with a comment called save. I don't recommend doing that for anything substantial, but for your, for your home lab, notes and stuff, there's really no need for you to have a really extensive commit memory and so that kind of thing, or to ever branch your PR and then merge it back in and all those things. You don't need that. This is just a method of backing your code up. When you get to a substantial project, just know that you can add on to this, your Git skills that you have now. You can add things on to the top of that, and you can do all those other cool things. But right now you don't need it. Right now you just need it as a backup mechanism. And so you could use git stash, yes. So git stash is a different thing. The git stash just saves all your changes up into a stashed thing locally. That's only really a thing if you're trying to pull down changes or you've made changes and you want to keep them and then pull them down and then thing. But none of that is relevant right now because the only thing we're doing in the lab is we're backing up our notes while we're developing in Bash. So let's get back to the Bash coding. We've got another 40 minutes. So add commit and push is effectively only for the current directory that you're in. Yeah. And I've never done that outside of the directory. Those are the main commands though. Eventually you're going to do a git pull to get the latest changes, but you only need to do that if you made changes to the repo someplace else. Right. And by the way, let's actually take a very realistic situation where you might do that. Let's do that, Dale. Okay. So let's try this. Let's teach you pull in a relevant practical purpose, which is I thought about something. I don't have my terminal. I'm on my phone accessing the YouTube or the GitHub API, the tool, or I'm on another computer and I just want to take a note really quick and I want to have it back at home on my terminal. All right. So let's that's a very real scenario. So let's do that really quick. GitHub, let's do Git. So we're going to open up the web page, Git repo view -- web. That's going to open up your web browser, whether you're on WSL or Linux or Mac. It's going to open up. This is the reason Terminal Velocity is on your workstation system with an integration, not in some container or VM, because that wouldn't work that way other than WSL, which strictly speaking is a VM. So container personal lab stuff. So let's say that your grandma's house on Thanksgiving or something, and you want to make a change. You're talking to your tech friends, and at the dinner table, and they tell you something. You're like, oh man, I need to take that down before I forget. So you either get on your phone, which you can do. You can get on your phone and thumb away all the little notes that you wanted to do, or you can borrow their computer, but you obviously don't know how to SSH into your home system yet. So you don't have your laptop with you. You just want to take a note. You want to change something to the web interface. So you come in here and you click on, there's a million things you can do here. You can just click here and hit it and then edit this one. Okay. I'm going to cancel those changes. This is kind of a fun one, but if you can actually, for a long time, this is how we did all of our coding before I taught people Vim or anything. We just clicked on code right here and we would say, code spaces. Okay. Where is it? What is it? It's like, is it dot? I think it's dot. There's some place you can put dot. I can't remember which one it is. There's a way that you can actually make it open it in edit it. Is it .dev? Is it github.dev? Yeah, you can do it at github.dev and it will open up the editor. Okay. Yeah, it used to be something else. And by the way, this is probably one of the reasons that you should learn GitHub. When I do CodeMage, we're going to learn VS Code because it's built into GitHub. Your extension GitHub repository wants to sign into GitHub, allow. Okay, so it's signing in. It's doing all of its thing. Is it slash? I think it is slash. That's the quick key. You're right. It is slash. It is absolutely slash. All right, so this extension wants to access the Git account. I want to do it as RDBX Rob. Okay, so now there's my thing. I can say, I can go in here and say that's the preview. Here's the README, and I can put the dot. Now, so if you want to do terminal editing here, I mean, it's kind of slow. I'm not gonna lie. I'll put a period there. All right, so you can actually save this. And where is save? I forgot. It's been so long. So here we go. So here is going to tell you how to save it. Your changes will be committed and immediately pushed to the main branch on GitHub. Don't show again. Commit and push. You can put a thing here. It's like add period. You remember that comment thing that I showed you? Same thing. You just put that there. All right. So last thing I want to practice here is I'm almost positive. So I was trying to figure out the quick key for this, and somebody says it's slash. So if you come up here, let's like refresh this, right? Refresh, it's got a period. Let's say I want to edit on it. So I push slash on the page. Nope, that's not it. It's not it. I don't know which one it is. I think it's dot. Yes, it's dot. It's dot. It's not slash, it's dot. So how's that for a quick key, my friends? That's dot. I knew it was dot. I couldn't remember where to type the dot though. So anywhere on the web page, like anywhere on the web page, if you just type dot, it'll open up that page in the local editor and throw you into it, which is pretty damn cool because it works anywhere. And, it's full blown VS Code, which is designed to be webified. So this, why am I doing all of this? Because this is a very real time when you would make a change, especially around the holidays. And now you're screwed, right? Because now you just made this change here. And now what? All right. So what if I go in here and I'm making another change, another thing here? What if I even put a period here? Right. And you're like, I swear to God, I changed that. I'm going to just add it here. Right. Okay. But now watch what happens now. Yeah. Git add dot git commit -m add period. Now we're going to have a conflict. Git push. It's like, oh crap. Right? So that is not good, right? We have a merge conflict. Oh no, what are we going to do, right? So we could do, instead it says, oh, okay, so we're going to try git pull. We git pull it down. It's like, oh my God, what is this all about? Okay, this is because it doesn't know how to resolve the changes in your two things that you changed. So we need to set it up to do this. I do the merge rebase. So git config pull. I swear we're going to get back to the bash. We were going to get back to the bash. This is web view. Absolutely. You just push the period and it'll automatically load it. Pretty cool, right? Yes. Your poor computer. I know it's taking forever. All right. So now let's do git pull again and see if it's smart enough to resolve the changes. Merge of the made. So it's making an automatic commit. You're like, okay, merge made, git stats. All right. So, okay. So it says we have 2 commits to be made here. So let's actually go ahead and make those. Git push. All right. So let's go open it again. GH repo view -- web. Let's go look at it. And we see here that it's there. We can actually click on, or is commit history. I'm trying to find a commit history. I think it's right here. Oh no, there it is. See how it said 6 commits? You click on 6 commits, and there's all the commits, and you can see what they did and everything. Okay. Anyway, so that has been a situation where I've made a change and I want to do that. We just covered everything you need to know about Git. There is one other case we could use git stash if you've made changes that you want to pull down other changes. So let's say you wanted to do that, and you could do a git stash and that will store them, and you could do a git stash pop and you can go look at that. But yeah, so that's the thing. Save and start a new one for bash. Yeah, well, it doesn't matter because it's holiday. This is all going in holiday boost. So yeah, this video is going to get renamed into the boost video. So anyway, here comes more bash. So now let's do bash. So Chloe, make sure to make a difference about bash right here. Okay. Because this is a thing. The next 30 minutes, we're going to go back to bash. And so what do? We got a lab and we need to make some stuff here. So let's make our foo file again. This is a good practice. If you haven't done this before, go ahead and recreate it. You can copy it in if you want. If you have it in temp foo, you can just copy it from temp foo into dot, and that'll move it into the current directory, which we don't have. Okay, but now we're going to go ahead and make a new one. So touch foo. Actually, let's use a better name. Let's call it greet. How about that? We'll call it greet. Touch greet. And now we're going to chmod plus x greet. And you might want to start putting all of these, stuff in here. It's like you could say we're going to learn Markdown. You should have already learned Markdown. So we're going to say chmod plus x file. And you could I'm just being you here. So, you can put like a note here and say, make text file script into an executable script. All right. So you put that there, you get the point, right? And so there we go. Now you got greet here and you can say, okay, so your notes should be taking form, my friends. Like, what is a shebang line, right? What is a shebang line? I'm just giving you a sample of what you could, start writing. And if you wanted to, you could put slash, hashtag bang. Anyway, let's type greet is affected by using space dash. So notes within a script is affected by using space dash space. Notes within a script. Oh, comments. Okay, let's do a shebang line. So shebang line user bin env. Why am I using user bin env bash? Why am I doing that? Right? And then let's do our thing again. Let's do lang. We had lang equals French. You guys remember the rest, right? So then what? We had case lang in, and then we had French, and we had greet equals French. I mean, you could have it be completely different here. You could have it be a string if you want. You could say salut, right? All right, so, and then over here, Isaac. If it's not doing the coloring, the fastest thing is just close it and reopen it. Yeah, I am absolutely anti-user bin env. I hate it, but it makes sense if you're writing scripts for all over for everybody to use. For yourself to use, it's fine. It is for yourself. For yourself to use it, it's fine. If you don't, just know what you're getting into. And this has largely been influenced by the fact that Homebrew is in a different location, and you don't have transportable scripts. And so, we talked about that. Okay. It is insecure. It's completely insecure. Yeah, it's completely insecure. You should not do it for anything but your own scripts. Because anybody can put any program named bash in the path and take over whatever you're doing if you're putting it in a multi-user environment. You should never do this in a multi-user environment. Do I need to put that there? Never do this in anything but your personal scripts. Yeah. I could say, how about that? Does that make you guys happy? I should probably have called that out. I made a whole video about this. Yep. But fully qualified path on the bash exe, it will break. But you can't use the script on WSL2 and Mac at the same time. That's what will happen. And I don't want that. So I want to use my scripts on both things. So if Mac hadn't been completely stupid and actually updated user bin bash, then we would be fine, but we're not because Apple's full of crap. But we're left holding the bag. All right, so I reopened it and now it knows everything. So we have French here. Your greet appears unused. Okay, so and then we can do this. We can say, how about this greeting? So then we can say echo greeting. And we can put the world in here. We did this already, but let's just catch up again. So there's the world. Russian. Actually, let's do Spanish. Spanish is hola. And I'm just going to have the 3 because I don't want to waste time on that. I could do Russian, but I feel bad because I'm not actually writing Russian. So French and Spanish, let's just keep that for now. Okay, so let's see here. You got this, you got this. Now, wouldn't it be really nice to be able to reuse it? So let's say if you have a greeting and, but wouldn't it be nice if we could ask them what their name is? So let's do that. This is the first moment of interactivity that we're going to add. So pay attention. We got 30 minutes in here. We're going to try to keep it. So wouldn't it be great if we could actually ask them what their name is? So where would we even put that? We can put it at the beginning up here. We can put it down here. This is where code organization kind of gets interesting, right? So let's put it up here. It would be sequentially, it would be up here. So let's put it up here. And let's say we want to ask a word here. So we want to say, and this is where we're going to use the read command. So read, we could actually do this. I mean, you could probably figure this out. You can say echo, actually, let's do this. Let's say, how about, let's say, let's say this. Let's say greeting, let's do this. Let's make this more fun. I'm trying to remember how I used to do it. So let's say echo, hello there. What's your name? Okay. And let's go back to our ENTR. What happened to my bash RC? Did I kill my bash RC? Please tell me I didn't. I did. What the hell happened? Did I do it live? Did I wipe out my home directory live? I think I did. Where did my... Christmas. Hey, hi, I'm making a video. Oh my gosh, what is it? My safety kit? My reloader thing? Okay, I'll do the thing. I just blew away my thing. That was a lot of things in. Okay. CD dot. I'm like freaking out right now. What the hell did I do? Did I run an accident? Cleaning up files? I don't know. I don't have a bash RC anymore. I have no idea where it went. Oh, it's pointing to .2. Oh, you know what it was? I was cleaning out my home directory. I don't know how I managed to do that. Yeah, this is just me. This is fine. The files are all still there. I got a little overzealous in my cleanup. So, by the way, this is the reason you should write a dot script, right? So now to get them all back, I just have to run setup again. And everything comes back, including my Westterm stuff. So, let's do this. Let's do exec bash -l. Yeah, now it's like totally messed up. Yeah. Okay. Well, did you see how it resized everything? Yeah, that was kind of fun. Anyway, so that's why you want to have your dot files in a script so you can get your stuff back. Your whole files more than me. Yeah, I mean that's why that's what I just did. So this is why you need a dot files, people. It did it added back the colors. It fixed a bunch of things. So that's why you want a dot files. Good little moral of the story there. Um, we were going back into lab what sample. So all right, so here we are, and now I can go ahead and run it. In fact, I think I have. Did it kill my colors? Let me just check. I want to check. No, I'm still got them. Okay. Um. So what are we doing here? Well, we came in here because we wanted to run the program. So ENTR, in case you don't remember it, ENTR bash dash z clear, and then we're gonna run it /greet that says run the program right here, and we're gonna only run the program when the program updates. That's what that does. So now we got Salu. Okay, so and the font size is a little bit smaller than I would like. Let's go zoom it in a little bit. Oh, all right. So are you guys in this? Oh God. It seems like it resized it a little bit. Yeah. Left drag. Look at that. It even said the left drag thing. That's cool. Mm-hmm. I know you guys are frustrated by my... All right, here we go. Echo greeting. What time is it? We got time. So echo greeting. It's just echoing the greeting, but it's not doing anything because there's no French. We have French equals greeting equals salut. Greeting. We want to have like a name here, but there is no name. Right? Wouldn't it be great if we could get a name? All right. Enter the read command. So read name. All right. So now what? Now it's going to prompt me for the name here. So now I have to type in a name. I say Rob, and it says Salut, Rob. All right. We got some commas in here and stuff we don't need. So let's get rid of that. What's your name? Rob. Salut, Rob. Why is it doing that space thing? Greeting. Why is it doing the extra space? Oh, right. So, salut, hola. How about that? Type the name in. Yeah. Yeah. The entire day to get to read. I know, people. It's hard. So, what does read do? Read reads one line of text from input. That's it. And it does not care about spaces and stuff. So, it'll put the spaces in there. What does that mean? So, like if it says read without, so this is actually a shell check thing. Read without -i will mangle backslashes. Remember all those backslashes and stuff we were doing? So just always do -r. But there's actually one other thing you could do. I'm not going to do this, but you can do this. You can do P here and put both of these into a single command. Right? If you want to do this is why it's a little hard though, because you got to put it up here and like this, and that does the same thing. So the P does the same thing. It just prompts in one line. If you prefer writing it all in one line like that, you can. There's absolutely nothing wrong with writing both of this as two separate commands, in my opinion. Wait, we got rid of name. See, this is why I don't like it, because it's too hard to get to the text to edit it. So I tend to do this. I tend to just echo whatever I'm going to say, or printf it or something, and then just write it afterwards, and just leave off the -p. So, wait, let's do DAS. Oops, nope, it doesn't work there. That's weird. DT, cool. There we go. And that's just my preference, but and ROB, salut Rob. Okay, we're gonna get to the next thing now. wait, what am I doing? All right. So, right. So there we go. And, you know, this is now about this time. It gets kind of fun to add color, right? Wouldn't it be fun if we could distinguish, the color? So let's start talking about terminal colors really quickly. I'm not going to get into the deep-seated parts of this. If you want to, in my dot files, there is a command called term color, and so you can actually run it here. I'm doing the bang bang to do the inclusion. I did exclamation point term colors, and wait, where did we lost our screen keys. Huh. Interesting. Screen. Sorry guys, I gotta look at this up. Nvim screen key equals 1. Something about my basher, he killed my screen keys. I don't know what it is. I don't know. We don't have time. I got to finish this. All right. So anyway, here's the color. So we got our colors back. So this is bash, and this is POSIX. We're going to delete that DAF or DAP to delete it. And so we got all these colors, but we're not necessarily using them. So let's comment out the ones we're not using. Now you can do this, and this is one of those cases where you could use visual mode. Or you could just, do them all at once. So, you can do the whole thing, or you can do them all at once. If you want to do them all at once, it's like this. I don't have my screen keys. I don't have my screen keys. It's not even worth doing this if I don't have my screen keys on. I killed him. Why isn't my screen keys on? I killed him somehow. Wait, is it just off the screen? Oh my god, it's been on the whole time and I just had my screen keys were too high. God, I'm glad I showed you that. The whole time it was working and I just couldn't see it because I was looking at the same thing as you guys are looking at. It was there the whole time. It's time for me to stop streaming. It is. It's time for me to stop streaming, friends. All right, so we're going to do this. Boom, boom. And we're going to send CMT, which is a program I'll show you how to make, and that'll automatically comment out everything. But let's say that we want this to be cyan. So let's then enable cyan, and we'll do cyan here. Okay, so got to have a space. Uh-oh, but what if we... Yeah. Oh, hey, look, it's all cyan now. Hello. Oh, but we don't want the words to be cyan. So let's change that. By the way, you see how it shot them together there? There's another way to do this, and that is by wrapping it in curly brackets right there. So it's called mustaches. And hello, what's your name? Now, we don't want that part to be the same color, so we're going to put a reset in here. And you can look up these values. You just have to look them up. These are special terminal escapes that we won't get into, but they send invisible sequences to your computer so that it, makes colors on your terminal. That's the takeaway. So now it's this. Let's make their input really special though. So let's make the color of their input maybe, gold. So let's put yellow here. If we put yellow, let's go use yellow. And then after we take this, we got to make sure to echo a reset to the screen. Otherwise, it'll all be yellow from that point on. So we're going to echo a reset, and then we're going to undo yellow and enable that. And now when they do their thing, you can do that. Hey, how are you doing? So, Rob, all right, it didn't do my yellow. Why didn't it do my yellow? It didn't do my yellow. I wonder if I have to do a -P with this. I don't know. Let's check. Rub. Yeah, there we go. All right. So actually, I think this one should also work. I don't think I just reset. All right. Yeah. Okay. So you see how it's like Rob and it says Saudi Rob. And then we can make anything it says a different color as well. But the point of this is that you can add color. And by adding, so here's and generally how the colors work is you add a color signal and then you have to have a reset, but you can also change the color and then eventually have a reset. That's all it really takes to do color, and you can do all kinds of fun things with that. So I wanted to show it to you. It does make your interface slightly more fun. You can get into ANSI escapes. We're not going to do that. There's literally, you can do millions of colors. I suggest you don't do anything more than these standard colors because they're supported on any terminal ever that has color. So there you go. All right. So that's been enough of that. But this, wouldn't it be great if we could like put all of this, we want to do something else. So let's say, I don't know, what if this was the beginning of a story game, an interactive story game? Like maybe we wanted to ask them something fun after this, right? And use their name, but we want to do something after this. So we want to say, Echo, do something else. And, and maybe we don't want to, we want to test that other thing. And this whole name thing is stopping us from writing the next code because it's getting in the way. And so that's kind of a problem, right? So it's like, our interactive test is kind of just broken because it's like constantly stuck on this interaction. Wouldn't it be great if we could just turn that part off for now because we got it working? And this is where functions, and they're technically subroutines, functions, subroutines, and procedures come in. So this is one of those terminology things. So the terms that we're going to use here is the generalized term, and I'm going to get crap for saying this, but it's better. The generalized term for a block of code that is kind of set aside to do something when you want it to is called a subroutine. And that term is very, very general. And the people that are going to complain are you talking about functions? No, yes, and no, right? Are you talking about procedures? Yes and no. Are you talking about methods? Yes and no. So if you know what those other things are, all of those things qualify as subroutines. They're just code that you put away, steps, instructions that you've set aside somehow to be called later, right? And at the very, very low level in assembly, they're called subroutines. So that's what we're doing. So we want to take those steps that we just did. We want to group those steps together into what we'll call a subroutine for now. Very frequently, you'll see the keyword function associated with this, even though if you know functions from math, you know that a function always has output, and people kind of use the term function in bastardized ways in computing for lots of reasons that we'll get into another day. So for right now, what we're going to do is we're going to say we want to put how much of this do we want to put in here? So how about this whole prompt your name thing, right? Can that be a group of things? So let's do that. So let's call that, what should we call it? Let's say, I don't know. I usually like to start these with a verb. So prompt for name. And right away, somebody just yelled at me and said, you can't use dashes in names. You absolutely can. You can use dashes in names because this is bash. You can in shell, but you can in bash. And we're writing bash code, and we're never going to write POSIX shell code because there's no reason to. If you need to go back in time and write a POSIX shell script so that it'll run on some esoteric AX machine, and there are many reasons you would need to do that, be my guest. But you have bash, you get to use bash. So in this case, we're going to use bash. This is not the kind of program that I'm going to be running that needs to be compatible with every system out there. That is a separate topic. And yes, that's a valuable thing. There are lots of reasons to write POSIX shell scripts out there. None of them apply here. The very nature of the reason that I use userbnenv is because I'm writing a script for myself on my own computer. The same reason that I'm using NeoVim, the same reason that I'm using Tmux, the same reason that I'm using WesTerm on my machine and not a container or a VM. And there's going to be a lot of Linux and Unix people that are going to see this video and go, what the hell? This is not proper training for Unix. You should only teach them POSIX scripts. You know, I'm not doing that. The first reason is POSIX scripts are insecure. And this number two reason is they're not that compatible as you think, and they're also not needed everywhere. So it's more important that you write your script in Bash to begin with, and then downgrade it if necessary to put it on something else. And that is a very modern approach. I understand that. There are a bunch of boomers who just lost their shit because I said that. That's okay. That's the way I'm teaching you to do it. That's the way you should do it. If you want to do it some other way, that's fine, but you're totally fine to do this. It's easier to understand, it's easier to write, and it's totally legit. Somebody else is going to tell you that you need to put a function keyword here. You don't. You don't need it. You can just write this. It's faster to write. It's convenient. It's easy for you to process. Hell, we're using ANSI colors here. You wouldn't put that in a professional POSIX Unix script to be deployed to AX systems on millions of machines. You should be able to do that, but not at this time. That's not what Bash is for. So you need to downgrade. You want to use it. In this case, the whole progressive enhancement thing about learning shell first and then learning Bash second, I've changed my opinion on that. I used to do that. I did that for 10 years. I taught people. That was what I did. I don't do that anymore. Because it's more important for you to learn Bash first and then downgrade when necessary. And if you need to upgrade, you can upgrade to Perl or to Python or to Ruby or to Go or to Rust or anything later. So Bash is a really great center language for your own personal script archive. And then if you decide that you want to take pieces of that and put them in your production deployment, then you can decide what pieces can stay and what can't. Okay. You would never put color there, for example, probably. You would never make it interactive, right? Because it would block and stop your automations from working. So I had to put that there because I'm going to get shit for this. So next, okay, we're almost done here. We're at 52 minutes. So we got a prompt for a name. Now we're going to go ahead. What about all this language stuff? What is that all about, right? So how should we do that? So what if we just put all of this stuff? This really doesn't belong in anything. Why don't we put this at the very top? So we'll put it up here. It's actually more important than these other things. So we'll put it at the top so people coming to the program can go change it. Spoiler alert, that kind of thing is set by the system, so you don't even need that. You could just change it for the entire system. Okay, so next we have this kind of lingering code. Let's put that around into something. What should we call that? Let's say, what should we say? We should say, well, let's actually call it greet. Let's call this one greet. All right. Okay, so we're going to say greet name. Greeting name. But now we have a problem. How do we get name? Where does that come from? We have the prompter name up here, and that sets it. And then down here, is it going to work? It actually is going to work. And, but it's not going to be what you think. And this is kind of a problem with shell coding. So let's go ahead and get into it. Let's go ahead and start our test again. All right. So it says do something. So it just went right ahead and did something. What happened? It didn't run my program, right? That's what we wanted. It doesn't do anything until you tell it you want it to do something. Okay. Yeah. It thinks do as a program, as a thing. So I'll put that in a string. So it's not doing the other things because we didn't call them. We put them in the groups, but we haven't called them. So I can actually do this. I can say prompt tab. Oh, it's not seeing my prompt. Yeah. I have a question. I wonder if it would do it if I did it like this. I'm just going to see if my completion works this way. I don't think it does. No, prompt. Nope, it doesn't. Yeah, this is a shell problem. I think if I had tree sitter, it would probably do it better. But I don't care right now. All right, so we need to have prompt dash for name, which I don't know why it's not doing. Normally, it would. If you tab, it'll give it to you, but it's not for some reason. That's an. I don't know why it's not doing that. It should have done that. So I broke my Vim somehow. I don't know how. Anyway, prompt for name. That's just running it, and then after we get the prompt for name, we can say greet. So that'll be the next thing. Right. So and if you want to, you can put a line here if it makes it easier. You could say like main or something, right? And I'm going to put this here. I have a little script that does that. And put the little lines in there. So this stuff, so here's all your functions. I mean, functions, procedures, subroutines, whatever you want to call them. They're all up there. And then down here, we've got the actual main program that's running. And spoiler alerts, in some languages, there's actually another function called main. In this case, it's implied. It's implied that that's main, but I put main there just so you get the feel for it. And as you can see, you can mix it up with calling these other sort of little programs. They very much are like little programs inside of the bigger program. That's why they're called subroutines, and or procedures of whatever language you're using. It depends. But so let's go down. You can see there's some problems here though, right? Because it's here it said prompt for name, but it's doing prompting for name. Is it actually doing it, right? It says read the name and then echo reset for the thing. And then it keeps on going. So let's go see if we can get it to do what it's supposed to do here. All right. So actually, we're just going to run it this time. So /greet. Yeah. RTFM. Yes. And here we have prompt for name, command not found, because I did the wrong name. I typed it wrong. So it's prompt for name. So let's go down here. Greet. Hey, let's see. What is your name? Rob. Salut, Rob. Do something else. All right. So this is something that's both scary and good. And we're going to introduce the idea of concept of scope, and that'll be the last thing for today. So this here group, this function here, has a variable called name. And it might be intuitive to say that, oh yeah, since this group of, instructions was executed first, since this subroutine was run first, therefore down here it knows about name. If we did it in the opposite order, it wouldn't know about it, obviously. I mean, it would be weird, but let's try it anyway and see what happens. Let's try to change the order and run it that way. If we do it that way, it says salut, nobody, and then Rob, and then it just throws it on the ground, right? So it is true that variable, as long as it's in the right order, gets, does the right thing. But there's a problem. This is technically kind of bad because you don't want everything in the global space. And this is another reason to use bash instead of POSIX. What I'm about to do cannot be done in POSIX shell. Everything is what's called a global in POSIX shell. That means all variables are readable by everybody in the entire program. And you might not know why that's a bad thing yet, but suffice it to say that you have variable collision. So maybe you'll make another group of of instructions, set of instructions that wants to use the name. Well, now you can't, because the other one that you don't even remember that you made, and right now we're using the same file, but as soon as you start using multiple files, which is kind of dubious when you're talking about shell anyway, but let's say you did, then you might have somebody's name is colliding with your other name and the other one is blowing it away. Okay, so now this is the first time to introduce the idea of scope to you, and this is going to be the end of this video. Variables scope. So I wanted to get to the function thing, or the procedures, the subroutines thing, and to the idea of scope, variable scope. What this means is that when remember I said these are like little programs inside of the other program? It's really key that you think about that. But in terms of let's try to make them even more encapsulated, right? And this idea is called encapsulation. So that means everything is all contained within that block. A block, by the way, is everything between the curly brackets, right? The curly brackets identifies the block in this case. So you can have blocks for conditions, like an if and case, like we saw. You can have blocks for procedures and subroutines and functions like we have right now. So a block is just any grouping of instructions or commands inside of in this case, the curly brackets, right? So what we want to do is we want to really make this really locked down, which means we have to say, if I have name, I'm going to lock it down, right? Now we know we're going to have a problem because we have to exchange between the two. So how do we do that? Well, the first thing we need to do is we need to start declaring what things are. So now in order to do that, we have name, right? Well, since we're now inside of a subroutine, we'll call it, you can do this. You can say local name, and that will define the name to be local. But immediately we're going to break something by doing that. So what we just said is that only this block can see name, only the block. Now, obviously, we're going to need it down below. I'm going to show you how to do that. But watch what happens now. If I type Rob, it doesn't know it. Why? Because we just protected ourselves by declaring that this thing is local. Now, in shell, because of the history of shell, everything by default is global. Everything is global. And anybody will tell you that that is a really bad idea. And in Python, you have to declare, everything's local by default. Every other language on the planet besides shell assumes localized scope. Every other programming language on the planet assumes local scope for safety reasons, and shell does not. Shell does not, because it's a practical thing and it's ancient. It's ancient. So Bash is inherited from POSIX shell, and Bash at least came along and said, you know what? POSIX shell is ridiculously hard to write anything in, because in fact, if you go look at old POSIX shell scripts, you'll just like shake your head like, what the hell is going on? Because they would literally create like these big environment variables just to hold the return values of everything and just kind of have to just agree not to stomp on each other. Nobody wants that. That's like a really bad idea. So if you're going to write Bash code, do it right and start by defining the scope of your variables by doing it this way. Right? Now, if you actually want a variable to be everywhere, you can do that. You could do it this instead. So here's one option. You could say declare instead of local. You can say declare name. Now name is like known to be a global that everybody's going to use. And now it's no different than it was before. But the difference is that now it's explicitly declared that it's like, hey, I'm going to use this thing and I'm going to reuse it. And there it goes. It works again. That's probably where you should leave this. But the last thing I want to show you is how to communicate from one thing into the next thing. And that is a very useful skill in Bash. And there's a lot of Unix shell programmers that are going to really roll over in their, and attack me when I talk about this, but we're going to do it anyway. So we're going to declare name as a private thing, right? Right. And we're going to actually, this is where we start to coming into subshells. So it says, so we read the name, right? Hello there. What is your name? And it prints out some cool stuff and then it prints out the name, right? Now, well, actually I take it back. In this case, we have to do the declare. This is a good place to end the video because we're doing the prompt and we can't read the thing from the prompt. So this is a good one to do that. But you could do this. You could say, there's one last thing we could do. Let's say prompt for name. How about we do this? How about we do read name? We could do that, right? So, yeah, I'm trying to think. No, I think this is better as a global. We could just keep this as a global. This is a good one. Well, because this will be a good introduction to functions later. And I can show you how to do a function in an actual function. So we haven't done that yet, but let's go ahead. So let's say declare, let's just do declare name. I'm going to say I'm going to use it everywhere. And then that'll be the end of this video. So we have a prompt, we have a greet, and the rest is a thing. Now it does say that the language is actually also kind of global, isn't it? Now we could do a couple of things here. We can make language local. So we could say greet in a specific language, right? Or we could make it so that, it's up to you, but you could also do it so that we declare, we also declare lang up here. Now, this is the language is French. This is actually one of those cases where shell check will usually complain. No, it doesn't. Okay, so there we go. We declare the language equals French and declare the name as a thing. And so now we have the declaration of global variables at the top. And that is good because you are always going to have global variables. And global meaning that they're visible to everything in the system. And this is why we're talking about this in terms of procedures, subroutines, and state. And we will eventually get to functional programming where this kind of thing is a big no-no, but you don't understand that particularly yet. But that's what we'll talk about next time. We'll talk about how to set up like a function versus a procedure. Both of them are subroutines, but what is the difference? And we'll talk about that next. And then we'll start to program. And we can continue to do all of this in Bash. Okay, so that's going to be it for me today. I am going to be doing some more videos tomorrow. So we'll pick up on this probably first thing tomorrow. And I assume I'm going to be done for the night. But so if you want to go ahead and start playing around with this, one last thing before we leave this, we made a lot of changes. We don't want them to get destroyed. Let's go ahead and add those changes back to, so we're going to get add dot. So that's everything in here, get status to see what I changed. And you see I have those two programs to change, get commit -m, add initial greet. And then get, actually we can do, yeah, get push, and then that will push it up. And if you want to go look at it, get repo view --web, that'll open it up. And again, if you wanted to change this stuff, just a reminder, you can do it in your own thing. So there's the get program right here. You can click on the greet program. It'll actually show you all your really cool code that you just wrote. And the really cool thing is that when you open up like this, now watch when I push a dot. Boom, I push the dot and it opens up the editor and it loads the code. I mean, that's pretty damn cool. I'm not going to lie. That's pretty damn cool. So like if you're over the holiday, if you want to continue to do your practice and you just have a computer or you want to use somebody else's computer, you can just go over there as long as you're logged into GitHub and you can work on your project. And this is why I think having GitHub for somebody who's learning is a great idea. Not only that, but you can share it with a mentor of yours and have them look at it and stuff. Is it true that you could have done this all on your own computer using like a bare Git repo? Absolutely. And if you're a hacker, you might eventually prefer to do things like that don't have any access to the public. But for now, you're fine. For now, you can share it. And if you decide to go public with it, you can. So that's the end of this video today. We'll continue to keep coding through Bash until we finish. But you already know a lot. You already know how my clone function procedure subroutine works in my Bash procedure. So you're getting to the point where you're going to be able to read about that. So we'll see you next time.